Good morning, everyone. My name is Yash Panjari, and today I'll be discussing AI-driven testing for conversational AI systems. I've spent the last decade working on voice assistants like Alexa and Siri, and one challenge remains constant. Testing conversational AI systems don't scale. In this talk, I'll show how we can leverage LLMs themselves as judges, test case generators, and automation drivers to redefine quality assurance for enterprise-grade AI. What's the challenge? Conversational AI is unpredictable. There's no finite set of inputs. Every user, every phrasing, every language variant can shift intent. For instance, users might say, set an alarm for 7, or wake me up at 7 sharp, or get me up before sunrise. Traditional QA assumes you can enumerate test cases. That model collapses here. Manual review is expensive, inconsistent, and cannot keep up with the pace of model updates. So the testing gap keeps widening. We build smarter bots, but test them with legacy methods. That's the problem we are trying to solve here. So our solution is an intelligent end-to-end QA framework. Our approach builds an AI-powered QA loop. It's built on three pillars: LLM as a judge, automated evaluation that replaces manual review, generative test data, AI-generated diverse test cases, and CI/CD integration, automation embedded into every build cycle. Together, they create an end-to-end pipeline where conversational AI can test, evaluate, and validate itself continuously at scale. Now, what is LLM as a judge? Think of LLM as a judge like an automated senior QA engineer, one that never sleeps, never biases, and scales infinitely. For example, given a chatbot's response, your package will arrive next week. The LLM as judge can analyze if that's accurate based on the context. Was it actually supposed to arrive tomorrow? It evaluates semantic accuracy, relevance, safety, and tone in seconds across thousands of dialogues. That's how we move QA from being manual and reactive to automated and continuous. Core components of LLM as a judge. There are four pillars: standardized prompts, structured evaluation templates like rate this response for accuracy, tone, and user satisfaction, calibration datasets, aligning the judge model's scores with human expert ratings, statistical validation, verifying correlation with human reviewers, and multi-judge consensus. Multiple models vote independently to minimize bias. For example, you might have GPT-4, Claude, and Gemini all judge the same dialogue, and only consensus counts. That's quality control through diversity. What LLM as a judge evaluates? Our evaluation spans across four axes: semantic accuracy. Did the AI actually answer what was asked? Contextual relevance. Does it remember and respond in context? Safety and compliance. No toxicity, no hallucinations. User experience. Tone, helpfulness, and naturalness. These become quantifiable metrics you can monitor over time, transforming conversation quality into measurable data, ensuring reliable bias-aware evaluation. Of course, automation doesn't mean abdication. We test across demographics and scenarios to keep surface hidden biases. We keep transparent scoring rubrics for auditability, and we use human-in-the-loop calibration periodically, ensuring our models stay aligned with real-world expectations. Bias-aware validation isn't just ethics, it's reliability insurance. Generative AI for test data creation. The other half of this framework is generative QA. Manually authoring test cases is slow and by definition limited. Generative AI can produce millions of realistic, diverse utterances, paraphrases, adversarial phrasing, multilingual variables. It can instantly create, how much money do I have? Or show me my account total? Or tell me if I'm broke. This changes the QA paradigm. Instead of discovering edge cases after deployment, we generate them proactively. This results in faster discovery of weaknesses before they reach production. What are the intelligent test data generation techniques? We employ several generation strategies: multilingual data for global consistency, semantic paraphrasing. For example, what's the weather in Paris becomes, do I need a jacket in Paris today? Or do I need an umbrella in Paris today? Same meaning, but different paraphrasing or different phrasing. Adversarial inputs. They can be edge cases like book me the cheapest non-cheap flight. It's adversarial, right? Or sarcasm, sure, because airlines never delay. Now, this is designed to break logic. So, an intelligent test data generation technique can generate such edge cases as well. Next is noisy utterances. Real world typos and speech errors like, can you book a flight for tomorrow? We can generate phrases and utterances like this. Test resilience to imperfect inputs. The point isn't to trick the system, it's to make sure it can handle how humans really speak. Schema driven prompting for controlled generation. To avoid chaos, we use schema driven prompting, formal definitions for what kind of test cases to generate. Each schema specifies intents, entities, languages, tone, and difficulty. This gives us automation with precision, the ability to regenerate consistent test sets for regression testing across releases. It's structured creativity, not random sampling. Automated annotation and labeling. Once the data is generated, it needs labels. We use the same generative models to produce expected intents and entities with multimodal consensus for reliability. Low confidence cases get flagged for human review, creating a closed loop system. This means we can fully automate from data generation to evaluation, dramatically accelerating QA throughput without losing quality. CI/CD integration for continuous QA. We plug all of this directly into the CI/CD pipeline. A code commit triggers generation of fresh test cases. LLM-as-a-Judge evaluates responses. Regression detection flags any quality drop. And deployment gating ensures only validated builds reach production. This gives us continuous quality assurance. It's like a QA that runs 24/7, not just before a release. What are the benefits? The payoff is massive. Less manual effort, the models handle the grind, faster release cycles, QA runs automatically, wider coverage, generative data explores the long tail, and continuous monitoring. Every interaction becomes a quality signal. It's QA that scales with your development velocity, not against it. Practical implementation insights. A few lessons from real world deployments. Start with high impact user journeys. That's where ROI is highest. Define quantitative KPIs like accuracy and safety scores. Keep humans in the loop, especially for emerging topics. Version control your prompts and schemas. Treat them like production code. And regularly update your judge models to stay aligned with LLM advancements. This discipline is what turns research ideas into production pipelines. Building future ready testing pipeline. We are entering an era where AI tests AI, a self sustaining QA ecosystem. By combining automated evaluation with generative test creation, we gain both scale and consistency. It's not just about speed, it's about trust at scale, ensuring every conversational AI deployment is safe, accurate, and user centric. This is how we build the next generation of reliable, enterprise grade conversational systems. Thank you all. And if your teams are building or testing conversational AI, now's the time to let AI help validate AI. I'd like to thank Conf42.com for giving me this opportunity to speak here, and have a good day. Thank you so much.